So today we're going to take a look at what is a function. For the crinkling noise on the recording, that's my TA opening up a bag of crackers. That is just comically loud. Goodness gracious. So we define a function as every input must have exactly one output. You are literally going to be asked that on the test, and you need to write literally that exact statement. So every input must have exactly one output. So today we're going to take a look at what does it look like on, what does this look like on a table. So we normally have our X values and our Y values. Our X values are always our inputs. Our Y values are always going to be our outputs. Okay, so if I just kind of make up some numbers. Like so. Everything that we've written so far is fine. There's nothing out of the ordinary. All right, plug in a -2, we get a 5. You plug in a 1, you get a 7. You plug in a 0, you get a 9. You plug in a 1, plug in 11, you get an 11. Plug in a 2, you get a 13. So everything up until right now is awesome. Okay, this would be considered a function. However, if we added another input of 2, and let's say we got an output of 14, this part is sad. Okay, that's not going to be good. We don't want to plug in the same number and get 2 different outputs, right? If we plug in a 2 and get a 13, if we plug in a 2 again, we want to get 13 again. Okay, in this case, we plug in a 2, we got 13, next time 2, and then 14. That would make it not a function. Okay, so I'm just going to draw up two different examples here, one that is a function and one is not a function. So on this example, okay, we plug in a 1, we get a 10, plug in a 2, we get 12, 3, 14, 4, 16. Okay, but then we plug in a 1 again. However, it's the exact same output we got the first time we plugged in a 1. Okay, since these are both 10, then we're fine. So we'd say this is a function. Because every input has exactly one output. Okay, so you can have the same input twice, that's fine, as long as they both have the same output. They had a different output, like I'll show you right now. And then that would be no good. So in this example, we plug in a 1 the first time, we get a 5, 2 gets a 7, 3 gets a 9, 2 then gets a 5. That one's wrong too. Let me change that to a 7 just to make it more focus on the 1. Sorry. So 2, 7, 2, 7. So that one's okay. However, when we plug in 1 again, the second time we get a 4. All right, that's not good. So that would make this not a function. Okay, because the input of 1 gives us 2 different outputs. And another example you'll see a lot. People trying to trick you. So let's say we have inputs of 4, 5, 6, 7, 8, 9, whatever. And let's all say they have the same output. Okay, do any of our inputs have two different outputs? No, so we're good. Okay, it looks funny because they all have the same output of 0. Okay, but none of the outputs or none of the inputs have two different outputs. Okay, on the other side of that, if we have the input of 2 a whole bunch of times, okay, with different outputs each time, 5, 6, 7, 8, 9, that's not good. That's a sad face, okay, because one time you plug in 2 and you get a 5, the next time you plug in 2, you get a 6, then you get a 7, then you get an 8. That's not good. We don't want that. So that would be an example. So they both look kind of funny. Okay, we're here, all the outputs are the same, but that's okay. If all of our inputs are the same, but our outputs are different, that's not good.